Okay, hello everybody. Okay, so I'm going to demonstrate how we can determine the centroid of a parabolic spandrel by using the integration method. Okay, so let's see the problem. Okay, so this spandrel parabolic consists of height b and the base is a. Okay, so for the integration method, we have to draw the strip. Okay, you can choose either you want to draw a vertical strip or horizontal strip. Okay, so in this example, I'm going to use vertical strip. Okay, so this is a vertical strip. Okay, so this vertical strip dimension is dx. The thickness, so the height is a y. Okay, so and this point is a xy point, and this point is a b point. Okay, and the next step, you have to indicate the x bar e and y bar e. Okay, so the x bar e, okay, we know that this is the x. Okay, so this is x. Okay, since the distance from these coordinates to the y-axis, so x, and this y. Okay, so actually the x is equal to x bar e, and the y here at the vertical strip, the mid of this y is towards the x axis is a y bar e. So let's express that here. X bar e is equal to x, and y bar e is equal to the y over 2, since we have denoted that the y bar e is from the mid of this strip towards the x axis, so the y bar e is equal to half of the half of this y. Okay, so actually the equation line of this parabolic spandrel is y equal to kx square. Okay, so now I'm going to define the k. Okay, so based on the AB. Okay, so if you have any value of AB, or in other words the dimension of the spandrel parabolic, so actually you will get k in terms of a constant value or one value. Okay, so let me consider that x equal to a and y is equal to b. Okay, by substituting these coordinates into the equation of line, okay, so we will get that, sorry, b equal to k a square. So rearrange this, you will get k is equal to b over a square, and the equation now become y equal to b over a square x square. So we will work out the step in the following step by using this equation. Okay, by using this equation. Okay, so you know that in the lecture, the coordinates of x bar is equal to qy over a. Meanwhile, y bar coordinates is qx over a. Okay, So in the next step, we will define the qy, qx, and the a. Okay, we start with a. So a actually is a area of this spandrel parabolic. Okay, so it's given by dA. So the limit is a 0 to a. So based on this one. Okay. And dA actually is a area that can be based on the y dx. So it's y the height, and dx is the thickness of the strip. Okay. So let's we substitute that dA. So dA become y dx. Okay. So the y now can be replaced by this equation, okay, that we have defined previously. Okay, so this integration become b over a square x square dx. Okay, and you actually can put this b over a square outside the integration, so this become x square dx. So let's work out in the next page. Okay, so 0 to a, so b over a square, so this x square dx. So this by integrate them, so you get that x cubed over 3, 0 to a, so this is b over a. So let me check, is it? Yeah, correct. B over a square. So substitute the x with a. So this become a cubed over 3, and simplify them. So we'll get that the area is equal to AB over 3. So this is the area. Okay, so we have defined the E. Now we will find the QY. Okay, we will find the QY. Okay, so the QY actually is equal to x bar E dA. So the limit is 0 to a. So based on this base of parabolic spandrel. Okay, and actually this x bar E has been defined previously, where is equal to x. Okay, so it's equal to x. So we can replace that x bar E with x. So the integration become x dA, and this dA is a y dx that we have defined during the determine the area of the spandrel. Okay, so this one. Okay, so this integration becomes 0 a x y dx. Okay, so we continue up here. So, and actually at this stage you can't integrate the equation, because you have to ensure that all the equation must be in terms of x, because this integration is in dx. So you have to substitute the y based on the in terms of x. Okay, so actually the y has been defined in terms of x previously based on this one. Okay, so now the integration become x. So y is equal to b over a square x square. So b over a square x square. Oh, sorry. X square. So dx. So put the b over a square outside, because they are constant. So x become x cubed. So then you can integrate this equation, so you will get that x 4 power of 4 divided by 4. So the limit is 0 to a. And substitute the x with a. Okay, and simplified the equation, so you will get that qy is equal to b a square over 4. So this one is a q y. Okay, so we have determined the qy and the a. So now we want work out for the qx. Okay, for the qx, the integration equations is given by this one. So the limit is remain the same, 0 to a. So y bar e dA. Okay. So the y bar e dA actually has been defined previously, which is at the first page. Y bar e equal to y over 2. Okay, y over 2. Okay, substitute that y over 2, and dA is a y dx. Okay, so dA is a y dx, and simplify this, you'll get that y squared over 2 dx. Okay, now you can't integrate this equation because we have to ensure that all the term must be in term of x, because the integration is within the dx. Okay, so actually the y, you use this y that we have defined at the first step. Okay, by substituting that y, so this become b over a square x square over 2. Okay, so dx. So expand them. So the equation become b squared x 4 divided by a4 over 2. Okay. So this is a dx. Okay, simplify this one. You will get that actually we can put b squared over a 2a outside because they are a constant, and inside here is x power of 4 dx. Okay. Okay, then you can integrate this equation x power of 4. So let me continue up here. So integrate them. So this become x to the power of 5 divided by 5. So limit 0 to a. Substitute x to get to a, and this 0. So the result in bracket will be 0. So the equation now become b squared over 2a, a power of 5 divided by 5. Okay, now this can be cancelled out. So this become a to the power of 4. So simplify this, you will get that 10, a4 b squared over 10. Okay, so this is a qx. Okay, let me check. Is it my integration is correct? Oh, sorry. Actually, I have made a mistake on this. This is supposed to be a a4. Okay. So, and this is supposed to be a4, and that this become a only. Okay, let me erase this. So, actually, the equation is ab squared over 10. Okay, so this is a qx. Okay, so this is a QY. So actually we don't finish yet, because we just define the QX, and previously we have defined the area and the QY. Okay, now you have to gather them into this equation. Okay. Okay, let's rework out in the next page. Okay, so x bar is equal to qy over a. So qy has been defined equal to ba square over 4. Area is where is the area? Where is the area? Okay, so area is a AB over cube. So this become BA square over 4 AB. So this can be cancelled out. This can be cancelled out. So my equation become 3A over 4. Okay. 3A over 4. So let's recheck whether I'm done the correct operation. So B is cancelled out. A. Okay, 3A over 4. Okay, now find the y bar. So you know that y bar is equal to qx over a. Okay, so qx is equal to where the qx? Okay, so this is a qx ab square over 10. Area same, ab over 3. So this become ab square over 10 multiplied with 3 over ab. So this be cancelled out. So this become b. This can be cancelled out. So simplify them. You get that 3b over 10 for the y bar. Okay. So let's say you have a value of a equal to 1 meter. B equal to 3 meter. Let's say. Sorry. Good number. A equal to 3 meter. B equal to 1 meter. Okay, so actually you can get the centron of parabolic spandrel. So 3 over 4a is equal to 3 meter, so 9 over 4. Okay, so meanwhile for the y bar 3, so b is 1 meter over 10, so you'll get that 3 over 10 meter. Okay. So actually this is a general equation. You can use this general equation to get the if we have the dimension a and b, you can get the centron of a spandrel unit, the parabolic spandrel unit. Okay, so that's it for this lecture. Okay, thank you.